So let's talk about the division algorithm. So actually this is not an algorithm that we are discussing. It's a theorem and it's called the division algorithm, and you can look online to know what's the history behind this. What But it's a very powerful theorem. So what does it say is that if you have an integer a and another integer d, so you can always find some two more integers of the form which we call q and r, and their combination will always be equal to a. So formally what we can say is that if a and d are positive integers, then there always exists some unique integers q and r such that a equals to d q plus r. But there are two limitations on these numbers q and r. Although there is no restriction on q, but there is a restriction on r, that r is always greater than equal to 0 and less than equal to d minus 1. So we will see why this is important later, but just keep in mind that r must always be greater than equal to 0 and less than equal to d minus 1. So basically what we are saying that if r is equal to d, so we can put 1, we can increase q by 1 and make r 0, right? So I hope you are able to see this. So division algorithm is nothing more than when we first started to learn division, and we didn't knew that real numbers existed. We only knew that they were only integers, and we were little kids who could only count on our fingers. And when we were told to study how division works, we made something like this, and put an integer here, and we call this dividend, and we call this divisor, and we try to find out some number q and eventually leave that division here with a remainder. If a was completely divided by d, then the remainder was supposed to be 0, but if a wasn't completely divisible by d, then we had some remainder. So if we wanted to recreate this number a with the help of d, q and r, so what we could always do was multiply d by q and add r in it.